We're here at Sensor and Test 2025, and we're at the SciSense booth with Martin here. Martin, thank you very much for joining us.
Thanks, Elliott, for having me.
Cheers.
Yeah.
They've got some show and tell for us. They have a CO2 sensor, an air quality index sensor, and a battery condition monitor. Let's see what you got going on here.
Yeah, well, on this fair we present our new ENS190. It's a CO2 NDR sensor, which is made for indoor air use. CO2 is still some sort the standard for air quality. However, there are other sensor technologies we will speak in a minute. But still, we have it in our portfolio. It's new, and you're good to go for CO2 measurements. Quite easy. It's a UART interface. There's an I2C version in preparation. So we offer different interface modes and let's say 0 to 5,000 ppm of CO2 measurement.
Amazing.
Yeah. The second sensor, which is my favorite, is the ENS160. It is a metal oxide sensor, a 4 hot plate metal oxide sensor, which comes with a fully integrated ASIC, which offers you easy integration in your application. The I2C or SPI interface makes all the registers available. You get fully computed output. There's absolutely no need to do any computing on the host processor, which leaves more computing power for other things like a graphical interface. With this evaluation kit, you also get an ENS210 temperature humidity sensor. Typically, metal oxide sensors have a compensation technique, so we compensate for absolute humidity because we treat humidity like a gas. However, the cross sensitivity is pretty small, and if a humidity sensor is not available, you just can leave it away, and it's still good for indoor air quality measurements.
Amazing. So let's talk about the demo that you've got here. What are we showing?
Well, the demo we see over here is giving us a view into let's say a secretary office or a home office, so to speak. Typically, you're sitting at the desk working with your laptop, and while being inside, you breathe, and with breathing, you exhale CO2, you exhale VOCs, and this deteriorates the air over time. And what you can see, the numbers got up a bit, and the lady is now getting fresh air through the window, and the fan is going on. Okay,
so let's talk about integration into designs. We can get these from distributors?
They are available by distributors all over, so the standard one, DigiKey, and so on.
Amazing. Yeah. Footprints available, software integration?
Yes, we offer on GitHub, we have libraries for easy integration and easy setups, like with the Arduino platform. Arduino is ideal for setting up a quick test setup, and later on everybody can introduce his own microcontrollers and alter the code which is available.
Okay, so why would someone at home, an engineer who's watching this, choose to use your CO2 or your air quality index sensor over maybe something else that's produced on the market? What is the advantage here?
One of the advantages is that it comes with this integrated ASIC. So the already computed outputs make integration very easy. You don't need to have knowledge about the chemistry as well, because what you get is an equivalent CO2 output, which gives you an idea about the CO2 which is formed by people being in a room. It gives you a TVOC output, estimating how many ppb of VOCs are around, as well as with the ENS160 an index, AQI index output. The index is something which was introduced maybe 2 or 3 years on the market, which I like very much. It is giving you an idea about changes of air quality within the last 24 hours rather than real numbers. The numbers are sometimes a bit misleading, because we must say that the sensor comes in the price tag. It is not what can I call an analytical device. And sometimes when our customer benchmark this sensor, which comes for a few bucks, with high-priced lab equipment for a few $1,000s, it's a bit unfair. So the numbers should always be treated as an indicator about air quality and changes of air quality, and it's up to the customer which one he would like the most, if it is ECO2, TVOC, or the index output.
So one of the big advantages of this sensor is that you no longer have to take some random number value that's given to you, find some sort of formula in the data sheet, divide by a number that's like a 32-bit floating point value that uses so many cycles. It's all done for you. It's giving you what is almost a real-world value.
Right.
Beautiful. Okay, shall we go check out our next demonstration?
Sure.
All right, next demonstration. We've got a battery condition monitor made for lithium-ion cells. Tell Tell me, what's going on here? This is quite the demonstration you've prepared.
Yeah, well, lithium-ion batteries are in some way dangerous because they can undergo what is called a thermal runaway. A thermal runaway is when a battery comes into a critical state, overheats, and there is the moment where the heat up of the battery cannot be stopped. It's an avalanche effect.
Similar to it used to be happening in phones when they would start heating up, blowing up.
Completely
in your hands.
right.
Yeah.
And meanwhile, since a lot of electric cars are around, a lot of people now have these cells on their roofs. We see more and more around battery packs. And when a thermal runaway happens, this means really it is exploding. And it's exposing threats like a fire. And meanwhile, there was a bus depot in Munich and Stuttgart completely burning down at night while buses were charged. There were electric bikes who catched fire while being parked inside a house. And also, as you mentioned, phones and also with laptops, the batteries are sometimes overheating. Happily, this doesn't happen too often, but the safety sensor will detect a drop in resistance or in its raw signal the very moment one of these batteries starts to outgas, and the outgas happens in this critical state. And between the outgassing of pouch cells, for example, these are the little silverish flat batteries, and the thermal runaway, we have a certain time where we can cut off the charging and save the battery from exploding. On the other way, if you have a battery which catches fire, we clearly see also a gas event and can warn the owner.
Amazing. So this is a way to keep your technology safe. If you are monitoring a lithium-ion cell, you can know when it's about to thermally run away. Maybe you can give this information to a microcontroller, which could switch on an inline PMOS, which could completely cut your signal, saving your battery and possibly the wearer's pants if their phone were to blow up.
That's it.
Amazing. So what outputs are we getting from this? What measurements?
This sensor is quite new. We have it in an automotive version, so it comes completely qualified. We have interfaces I2C, SPI, which makes it again quite easy. It comes with an integrated ASIC, so completely computed output. Just read the registers, you get it ready to go. But since for automotive applications, for example, also the LIN interface is important, we added a version with LIN interface. So we have 3 different interfaces available. So I think that everybody can pick the interface of choice. Yeah?
Amazing. There's truly no reason not to use a chip like this. There's no reason not to be safe. Is there any reason why you wouldn't use a battery condition monitor?
Actually, it's the opposite. I highly recommend to use it, especially if you have battery packs at home for storage of your electricity you generate with your solar cells. They will add safety for you and your family. If you have a carbon monoxide detector at home because you have a fireplace, or you have a methane detector because you have a gas stove, then there is absolutely no reason to add this extra safety for your batteries in your basement, which give you an alarm if they are close to catching fire, outgassing, leakage, whatever.
Martin from SENSOR+TEST.
Okay.
Thank you very much
Thank you very much.
If you'd like to try out something like this, we'll put a link down below for all of those sensors. You can go ahead and check them out.